Okay, so let's talk about ignition coils. Since this is something that I seem to see a lot of confusion with, it seems to be one of the most common logical jumps that people make anytime they're diagnosing anything with a car. It seems to be always it goes to, oh, ignition coil, ignition coil, ignition coil. But the vast majority of those times when I delve into it with people who make those diagnoses, they usually can't explain why they came to that conclusion or even really what an ignition coil is beside the device that makes spark. So at their core, they're pretty simplistic devices. An ignition coil is more or less a transformer. Now this is where it gets interesting, because anybody who has a background in electrical would know right from the door that something's amiss there, because transformers don't work on DC voltage. A DC voltage, if you were to consider it akin to plumbing, would be a pipe completely filled with water. It's constantly got water going through it. There is constant voltage any given point in that pipe. Whereas AC is alternating, it pulses. So it would be the equivalent of you rapidly 60 times a second, because that's the frequency that most electricals run at least in the United States, 60 hertz. It would be 60 times a second you rapidly turning on and off a valve on a water pipe, and the water pulsing through that valve. There would be pockets where there would be air, and there would be pockets where there would be water. So those pockets where there's water go across windings inside of here, which are really, really tightly wound pieces of thin copper. Just think of it, an uninsulated wire, basically. And they're wound up really, really tight. And as those windings happen, the current pulses back and forth across there and creates a magnetic field. And that's what a transformer is that the pulsating of that magnetic field then goes to a secondary winding in there, which creates an output voltage. So you have a primary winding and a secondary winding. The primary winding feeds the secondary winding, which puts the output voltage on it. The input voltage on a car's ignition coil is 12 volts, because the electrical system for the engine management, everything like that, is 12 volts. So it's a 12 volt DC input into the primary winding on this. On the secondary winding, it can be anywhere from 15,000 up to 40,000 volts. So you get anywhere from 15 to 40,000 volts output on a coil. So now that we have a general understanding of what a coil is, well, how would one go about troubleshooting it? Pretty easy. Since you know that it is a coil winding, that would indicate that there has to be a resistance. In order for a transformer to work, there has to be some level of continuity across the windings. Otherwise, it's a completely open loop. It's an incomplete circuit. Inversely, the resistance being too low, it's basically just a wire. So what we would want to look for in this case, it's a three-prong ignition coil, which would indicate a common between the two, which would be the ground, and a probe for the primary winding and one for the secondary. I don't know which the actual order is in this case on this one here, but some variation of that. So what I'm going to look for here now is resistance outputs on the multimeter. So let's just assume that this is the primary winding and this is the common. I am getting nothing across there. So 2.5. So that would indicate to me, if that's the higher of the two, that that's the secondary winding, which would be the output. This is 1.5. So these two here would be your primary winding. I'm going to assume this is the common here in the middle with a 1.5K ohms resistance, and then 2.5 on the high end. So this particular setup here is a little unique. This comes off of a Mitsubishi, I think Lancer, if I'm correct. It's been a little while. It's been sitting in my toolbox there. So this is actually a wasted spark coil. This actually feeds 2 spark plugs. So it's firing 2 cylinders instead of just 1. So easy way to demonstrate that would be, if these are both being fired off of here, they would be in the same circuit. Let's see if I get a good bite here. Kind of hard in the boot. There we go. Which also indicates to me that both of these fire at the same time, which is the name, hence the name, a wasted spark. It's going to spark even when the other cylinder is not at the top end of its compression stroke. It's going to fire when, say, this is cylinder number 2, and I believe on these ones it went evens and odds, if I'm correct. So this would be, let's just say, 1 and 3. So if number 1 is ready to fire, it's going to ignite, even though number 3 here is nowhere near that point in its cycle. It's still going to waste that spark because it's an easy and simple solution. I only need 2 coil packs at that point. That little bit of wasted voltage doesn't harm anything, so it was deemed a worthy solution. It kind of got phased out some point in the 90s. I know GM used it for a while on their V6s. I had quite a bit of experience with those. They failed quite a bit, and they were kind of an odd one when they would fail, because sometimes you would fail only on a single cylinder of the 2. It would just kind of break off that circuit somewhere internally. But they've kind of been phased away, so you don't see them anymore, which is also why I thought this one would be a good example. So if you ever run into an issue where you're not sure if a spark or if a ignition coil is bad, you can always test continuity across it. If you're not usually it's going to be, this one's a little bit on the low end, but expect anywhere from 2.5 to like 10K on the higher resistance end. On the lower resistance, which would be your primary, usually about 1/2 to 2/3 of that. They're going to be in relation to each other. It's a ratio. But that would be kind of a general overview of ignition coils.